Hi, this is Rob again, and I'm in the middle of section 5.4, example number 4. When we last left off, I was talking about how to integrate and evaluate, basically finding area underneath the curve without drawing a bunch of little rectangles. So I think I had finished example A, the integral of e to the 2x. We did a u substitution, and we came up with the answer 1/2 times the quantity e to the 6th minus 1. I don't know why this author decided to round that answer, but they did. Just read WebAssign to find out if they want to do likewise. Let's try example number 2. The integral of 1 over x is a log property. I think we now know that it's the natural log of the absolute value of x. But you're going to integrate that not over the entire domain, but only between, find the area between 1 and 2. So remember, it's f of b minus f of a, and this is my a term down here, and this is my b term. So I'm going to plug in the 2 first and ask the question, what's the natural log of 2 minus the natural log of 1? Well, perhaps you remember that all log functions go through 1, 0. So hopefully you remember that the log of 1 really is 0. So this really says the natural log of 2 minus 0, which should just be the natural log of 2 for the area underneath the curve. And that's what the author decided here too. Again, they switched it into decimal form just in case they say round your answers to the nearest 2 decimal places. But the exact answer is the natural log of 2. This third example that they have here, again, we might want to dump the coefficients out front. We might need to use that coefficient as part of our integration. I don't know yet because I haven't done my u substitution. So let's try. If we do a quick let statement, 90% of the time I'm letting u be the inside function, and the inside function here is just, well, perhaps just x. Maybe it's x to the 1/2. I have a couple choices here. I could let it be x. I could let it be x to the 1/2. If I choose x to the 1/2, I could probably just rewrite it without even using a u substitution, because x to the 1/2, I think I know how to integrate without a u substitution, because our rules for integration says increase this x value by 1, so that'll make it 1/2 plus 2/2 is 3/2, and then divide by 3/2. Well, instead of dividing by a fraction, I'll multiply by the reciprocal. And it looks like I have this blue -3 hanging out here as well, which cancels and leaves me with the -2x to the 3/2. But remember, I need to integrate that between 1 and 4. So I'm going to do my f of b minus f of a again. If I plug in the 4, this really says take the square root of 4, which is, I'm doing my f of b here first, followed by my f of a. So the square root of 4 is 2. 2 cubed is 8. 8 times -2 is -16. Let's try that again. This time I'm going to plug in my a, though. So the square root of 1, because this means take the square root of it, and then cube it. So the square root of 1 is 1. 1 cubed is 1. 1 times -2 is -2, which is really -16 plus 2, which is -14. And the negative simply just means, it's not that it's negative area, it just means that the area is below the x-axis. I could draw a quick little picture of that, or actually if you were to graph this thing, you could see that the area does fall below. This might be a good example where I could actually show you how to check your solutions on a graphing calculator. Again, I want to see your work, but I don't mind if you check your work. If you have your graphing calculators, and go to your y equals and type in this function, -3 square roots of x, graph it, zoom 6, you can see that the area surely is below the curve, but let's try to see if we can get our calculator to tell us -14 by calculating the integral, which is number 7. So instead of scrolling down, I can just hit the number 7. Uh, and it's asking for the lower limit, and I'm looking here. The lower limit is a 1. I'll press 1, enter. The upper limit is 4. I'll press 4, enter, and immediately it shades the area between 1 and 4, and it gives me a nice solution, which I could paste back onto my original. So you can see here's shaded. The area is certainly negative because it's below the x-axis and between the x values of 1 and 4. Kind of nice that your calculator does that. Moving on, example number 5. This one is kind of interesting because it looks like we've got some area off to the left hitting a 0, and then we've got some more area off to the right. So it looks like maybe we have two problems in one. I think I'm going to integrate between 0 and this point, the vertex of, and then it looks like it's at a 1/2. We can double check to make sure that that root really is 1/2 by setting this equal to 0 to find the 0. So yeah, certainly 2x equals 1 when x does equal a half. So it looks like I can integrate between 0 and then 1/2, and then add, that'll give me the blue, and then add the 1/2 through the 2, and that'll give me the purple. So it looks like I'm going to have two integrations here. Again, the first integration would be, well, let's see. This is actually a negative slope. So by definition, absolute value has two different linear functions. And it looks like one of them is the line 2x minus 1, which I believe is this guy over here coming down, because that looks like positive slope. But this one is going to be the opposite of 2x minus 1. Or actually I could write it as negative 2x plus 1, because it looks like the y-intercept is a positive 1, and then I'm rising down 2, so there's 1, 2, and running 1. That's not really a point on the function, but that is the slope of this thing. So I think I'm going to start with this negative 2x plus 1. That's the negative slope part, and I want to integrate that between 0 and a half. And I'm going to add that to the blue integration, but integrating between 1/2 and 2 for the positive line, which is 2x minus 1. So our rules of integration say that we should increase this exponent by 1. This becomes an x squared divided by 2, but it looks like it's going to cancel with this 2, so just negative x squared plus, well, this is going to be an x, because this is really an x to the 0, and when I increase that 0 by 1, I get an x to the first. And I'm going to evaluate that between, should have been in purple, because this is the purple section, between 0 and 1/2. Then I'm going to add, I'll switch to green, this portion in green. So let's integrate this again. Looks like it's going to be kind of the same. Increasing this would be just x squared, but this time it's minus x, and I'm evaluating that between 1/2 and 2. So this kind of becomes a little bit of a number crunching nightmare. If I were to throw in the b's first, I would get negative. This is on the outside. I'm going to square this. I'm not squaring, I'm only squaring x. This is the opposite of this whole x term being squared. So the only thing that's being squared is 1/2. 1/2 times 1/2 is 1/4. So it's negative 1/4 plus 1/2 minus, that's my f of b, minus the f of a. Well, the f of a is going to be minus 0. That's not very interesting, but I'll write it so you can see it's there. Plus, let's do it again. F of b, oops, this should have been an x. I'm so sorry. F of b, because the integral of that 1 should be just as x. So f of b is 2 squared, which is 4 minus 2 minus, and remember, this is where I really recommend putting parentheses, because I have to subtract all of this. I didn't do that over here because I was just subtracting a 0, but might be helpful for you to continue to write these parentheses so you don't forget to distribute your negative sign. So let's do this again. 1/2 squared is 1/4 minus 1/2. So at this point, I could either pull out my calculator, or I could simply add this up by finding common denominators. I'm going to recommend that you just plug it into your calculator. The author has already done so, so here's the exact same thing. Just punch this into your calculator and see if you can't get that 5/2. And you can check that on the calculator. Marginal analysis. We're going to, in this section, see the business application for integration. We remember from previous sections that to find the marginal profit, it was the derivative. Well, what if you want to find the change in just the original function, the profit function, and the change in P? Well, if they give you the marginal profit, the derivative, of course, we're going to have to integrate the derivative, which doesn't look real fun to do because I've got a bunch of decimals, but it's really not that bad. Again, I'll use my calculator to do some number crunching. So let's do it. Let's increase the exponent by 1. So this 1 goes to x squared. And then I need to divide by 2. So if I take half of 0.0005, I think I'll get, of course, the negative just gets dragged along, or you can throw a negative 1 outside. 0.000, half of 5 is 0.25. And I'll do the same thing with 12.2. Increasing this exponent by 1 becomes a 12.2x. And of course, there's some plus c, but it looks like I don't need to say plus c because I'm going to do my f of b minus f of a, where it looks like I'm going to evaluate this between 100 and 101. So I'll throw in my 101, and then I'll subtract off the 100. And again, it looks like the author has already done that for you. Good. They didn't show a whole lot of work. So be careful with your number crunching. Check it on your calculator and make sure you can get $12.15. I'm going to do the exact same thing for part B. I use the exact same function, but instead of evaluating it between 100 and 101, it looks like they want me to go from 100 to 110. This time, again, I would recommend that you practice typing that in and see if you get $121.48. Average value is similar. We're going to tag on just one extra thing. Every time you see average value, we're going to take 1 divided by the b minus the a. And we don't have to do f of b minus f of a. We're just going to integrate the function that's given there. But this is the extra part to find average value. So just showing you one really quick example. We're going to use our average value definition. And the definition that we're using is this 1 over b minus a. And it looks like they're giving us our a term, our beginning term, and our b term. So if I do 1 divided by 24 minus 0, I just get 1/24. I'm going to integrate the function. Ooh, let's do that. I'll just keep it f at x, so I don't have to write the whole thing out. So let's integrate. I've got a 1/24 hanging out front. Increase this by 1 and divide by it. So t cubed, and then 0.005 divided by is a number that I'm not familiar with, so I'm going to just leave it. 0.005 divided by 3. I'll just number crunch this all in just a moment. This t gets increased by 1. So again, I'm integrating each individual part. So it's really 1/24 of all of each part. So I'll keep this 1/24 out front because each of these is broken up into little sums. So plus, this becomes t squared, 0.01 divided by 2. And then this one's going to be plus just 13.15t divided by 1. So again, we're going to evaluate then that between 0 and 24. I'll do f of b minus all of my f of a's, which is 0. So I don't think I have to do minus f of b because I think that'll be a 0. And the author has done that for us nicely and gotten $14.23. So in the next video, I'll talk to you about even and odd functions, and we'll finish up section 5.4. I hope this was helpful.